Sweet. Kia ora, I'm Peter Jakowetz. I am a security consultant based in Wellington. I run a small security company down there, doing kind of governance, risk compliance and pen testing work. My background's primarily in GRC, but I've done a little bit of a whole bunch of things. And I'm an electrical engineer by qualification, but I kind of like faffing around with British cars and playing with cheap, crappy electronics in my spare time. And I guess one of the things that I keep coming across, especially in the audit side of the work I do, is probably some misunderstandings around resilience, business continuity, disaster recovery, how to best approach those and kind of appropriate ways to test them as well. So I thought it would be quite a good topic to talk about today, just to kind of socialise some of those ideas and talk about a couple of little war stories from around the place as well. So what do you do if a disaster occurs and your service is suddenly unavailable? So this could be your web app, it could be your SaaS tool that you use, it could be the SaaS tool that you provide, or one bit of. So it's probably first a good thing to talk about what a disaster is. And so disasters are unexpected problems resulting in a slowdown, interruption, or network outage in an IT system. So it could be anything from kind of natural disasters, tech failures, things not gluing together very well, people making dumb mistakes and breaking things, people making smart mistakes and still breaking things, people breaking into things because they just feel like it would be fun. And they can all kind of have those, that consequence of breaking stuff and causing outages. And so it's often not that it just affects whatever the services that you're talking about when something like this happens. It might also go and affect the business operations that actually support that. So in the example of an organisation who has a contact centre, they don't just have a contact centre probably because it's fun to have a contact centre, they probably have it to go and support their business so that people from the public can go and call them up on 0800, whatever they are, and go and talk to a real person to get their problems fixed. And so if that contact centre breaks, it's actually affecting their business operations more than it just being a straight technical problem. Cool. And I guess one of the really good examples of this that's happened in New Zealand a couple of times in the last few years is, for example, when Azure AD in the Azure space has broken, and that's kind of just taken down like the entirety of government for like half a day at a time, because suddenly everyone comes to work in the morning, they go and log into their machine, oh, I can't even log into my machine, or I can log in, and now I can't log into my email, or I can't get onto Teams, and you've suddenly got a whole workforce of potentially tens or hundreds of thousands of people around the country who can't do their jobs. Sorry, and my notes are only showing up on my other laptop. That's super helpful. Sweet, and so I guess what's the problem here? We generally have a high confidence that our hosting providers will always be available, but that's maybe sometimes a bit of a falsehood. The likelihood of a Meteor strike, for example, is pretty low, but maybe for a geographic outage of a service, it's a bit higher. The likelihood of someone just making a mistake and causing an outage in the service is much higher again. And so when we're building systems and when we're maintaining systems, we really want to know, well, what happens if this entire data center is unavailable, this availability zone, this region? What happens if one of the key services goes down? So I don't know, if you've got a web app and you've got a Cosmos DB database in the background, what happens if Cosmos DB is unavailable? Does your entire app fail? Does it kind of work? Can you do some workarounds to keep it going? Or what happens? In a more traditional sense, what if one of your servers fails? What about that as a service that you kind of forgot that you were really reliant on fails? And so I don't know, that could be Duo for MFA, and now suddenly no one can actually log into your application because no one can go and pass the MFA. And kind of what do you do in that situation? Do you just go and turn off MFA and remove that and reduce the security posture of your service? Or do you go and suck it up, wait for Duo to come back up, and then go from there? And I guess a key part of this is having a good understanding of what the services you have and what else is reliant on it as well. It's something that I guess I've seen quite a bit around the place is a service will fail and people don't actually have a good understanding of how it all hangs together. A design document was created before the service was built, and as built was built when it got first stood up. And then there's been probably, I don't know, 5, 10 years worth of changes that have happened to that solution in the meantime, and no one's actually documented what those changes are. And so then when an outage occurs, you're suddenly going and pulling in that engineer who did that change 3 years ago to go, hey, do you kind of remember how this thing hangs together? Do you remember what that black box in the corner actually does? And how important was it for the service? And I guess, especially when I'm doing audits, I start talking about disaster recovery, business continuity, resilience, availability with people, and they go, it's all good, guys. We use Microsoft Azure, we use AWS, you don't even need to worry. We just use PaaS services from them. You know, it all just works all the time. But I think we've all probably seen over time that that's not really so much the case. This is a Microsoft services just around the availability SLAs that they provide. Even just straight out of the box, they kind of admit that you don't have 100% availability. You've got potentially 99.59s for Cosmos DB, Redis, etc., or kind of 3.5 nines for things like Azure Functions and some of the other cloud services. And in real terms, that is like real time. So like 3 nines still gives you like 8 hours of outages a year if they can meet those 3 nines, or kind of 4.5 hours if you're doing that 3.5 nines. And I guess these are always kind of aspirational goals for them as well. And they've built their systems to try and meet these targets, but it doesn't always happen either. So AWS had an issue a few years back where an engineer followed a SOP to do a small change in the billing part of S3, and they ended up killing S3. And so you kind of go, oh, that's not great. It affected 54% of the top 100 internet retailers in the world, which is a pretty big impact. And then when you start talking about money for that, it was $150 million for the S&P 500 companies and $160 million for US financial services. And that was just by the failure of S3 within Amazon for a small period. So even though they try and keep these things up, issues still happen. Microsoft has a cool page that just shows all their outages, and then they do post-incident reports on them all as well. And it just kind of shows that, like, whatever, in March there was three outages around the world that kind of required these reviews to be done, which I guess is pretty good for such a big service, but it still really, really impacts those who it affects. That multi-service outage in APAC was Singapore, I think. Southeast Asia and East Asia. And that took, so it was a cooling failure. So the cooling didn't kick in like it should have in one of the data centers, which then started causing things to overheat. And that caused some servers to turn off. And then that caused more servers to turn off. And then it was just kind of a catastrophic failure. The cooling failure started at 3 p.m. on the 7th of February. Most services were restored by 4:30 p.m. the next day. And then there were still some services that got restored at 4:30 a.m. the next day. So like a 32-hour outage is going to be pretty impactful for anyone who uses any of those services who was using that region. And by that point, you're probably trying to go and move services pretty quickly. But if you didn't have appropriate backups and documentation and the like, you're going to have a really bad time doing that. Because we're in IT, everyone likes acronyms to the nth degree. And these are the, I guess, the exciting ones that are well worth knowing when it comes to kind of talk about resilience, business continuity, and disaster recovery. And so we've got the idea of a recovery point objective, which is the maximum acceptable data loss measured in time. So this is how much data can I actually lose, and when's the last record that I needed. Recovery time objective, how much time it's needed to actually bring systems back online. So between a disaster happening and the systems coming back up, how much can that be? Work recovery time, the amount of time to actually verify the system's working and to make sure that the data's got good integrity still. And then the maximum tolerable downtime is the RTO and WRT together. So that's that total amount of time between something happening and you being comfortable that your system's back up and running. Because they're horrible terms, I put it on a terrible diagram. And so, yeah, so we've got like a disaster occurs here. And so that time between kind of things operating as normal and you having good records and that disaster occurring is your RPO. Your recovery time objective is then that disaster occurring and you recovering. And then the minimum tolerable downtime is the difference between the disaster occurring and you resuming production. And it's totally context dependent on the organization you're in as to what matters more to you. Some organizations and some systems, you're trying to minimize your RPO. Some you're trying to minimize your RTO. Some you're trying to minimize both. Some you just don't care. And one can be greater than the other or less than the other, and it's just absolutely business dependent. So we're really trying to minimize RPOs where we're trying to make sure that the integrity of the information, or where the integrity of the information is really critical. So a banking system, we've got bank transactions. You want to lose as few of those transactions as physically possible if you've got an outage, because if you've lost transactions, you've lost money, and banks don't really like that. They like to take your money, not lose it. And so in that kind of situation, you're going to find that they've probably got lots of high availability systems, that they're replicating to read-only databases, that they're doing really regular backups, that they've got a really high level of confidence that if any one system dies, that they're not actually going to go and have lost any of those transactions that have occurred. And then there's other services where that's probably less important, but they really need to make sure that that actual service is available all the time. And so they're going to be going and trying to minimize that time to actually recover the service, so the RTO. So I don't know, if you're broadcasting TV, then you probably want to make sure that it's up all the time, and you're going to have a whole bunch of redundant systems in place to go and make sure that if one component fails, then another just slips in, and that you're kind of reducing that time at all. If you lost historical stuff, who really cares? Like your emergency services is another example of something where you want it to be available all the time. You want that 111 number to be up all the time, so they're very likely going to have a whole bunch of redundant services there. And then sometimes there's things that are equally important. So I don't know, if you were doing an election and you had an electronic voting system, you probably want to make sure that you've got really good integrity over that information. So you want a small RPO, but you also, if you've only got voting open for a day, then you probably also want to make sure that the RTO is really small as well. Yes. And so where I'd actually, I guess, kind of seen that in real life, and it kind of talks to this one as well around loss of money, is because contact center solutions are things that always die, I guess. I keep thinking about them. I was in an organization and their contact center solution died, and they had a very eager chief executive wanting that to get up as soon as possible, because the contact center solution was how they called out and they got money every day. And it was something along the lines of a couple $1 million a day. And so if you've got like 100 staff working in your contact center and you bring in a couple $1 million worth of revenue every day, like every minute is about $4,100 per minute that you've got that system down. So suddenly people become really itchy if that service is down. Their RTO for that is really low. Other implications of it can be loss of productivity. So if your email goes down for your org, sad time. Reputational, public websites sometimes fall into this category of, I don't know, if the My COVID app had gone down and wasn't available, health at the time would have got a whole lot of slack for it because it was a really popular thing at the time. It can affect health and safety. So if your juris system and you've got people visiting people in the public and the juris system doesn't work, then that could be bad. If your 111 call center doesn't work, I don't know, it could lead to death. That's not great. And so they're probably going to go and put a whole bunch of effort into their resiliency. And kind of one of the, I guess, more interesting ones for me, I think at least, is like destruction of records and artifacts and stuff. So like if your environmental systems go down, so your heating, cooling, whatever, then that can be really impactful. Like if you've got a library of a whole bunch of old artifacts or something, and suddenly you go and lose your environmental services, and you can't get them back up in a reasonable time because you don't even know that they've died, then that can be really bad. Cool. So then I guess the next part of this is what's the difference between business continuity and disaster recovery? So business continuity is all around how do you continue to deliver business services in case of outages or service disruptions. So what's your contingency if a business disruption occurs? And so a business continuity plan talks about what manual processes can be put in place if something goes wrong, what alternative services can be leveraged. I don't know, if you've got a digitized system, can you go and crack out the paper and pen and just go and write things down for a couple hours if your digital system's down? So I don't know, if you've got a CRM, can you just instead go and write things down and then go and process them later? If you're taking people's credit card details over the phone and your CRM dies, can you go and write those details down and put them in later? Probably from a PCI perspective, no. But from a business continuity perspective, maybe. Oh yeah, and so an example of where I found this was kind of interesting was an incident had happened with a group I knew, and it meant that one of their services had to be taken offline. When you had a look at their business continuity plan for that service, they said that like their minimum tolerable downtime was like 24 hours. It turns out it was actually more like 6 months, because that system went down because it got hacked, and it took them about 6 months to get confidence that it had been rebuilt in such a manner where it could be stood up again. And so actually they had manual processes that they could do for 6 months that kind of satisfied the need of what that technical system could do. So sometimes it's worth kind of testing your assumptions around what your acceptable downtime, etc. is. Otherwise, you might be trying to build something to a level where it's not actually required, because there are other processes that can be put in place. And then disaster recovery is kind of the technical side of things. So where business continuity is looking at how do you get those business processes working again, disaster recovery is more around how do you get those technical systems working again. What do you need to do to actually go and make those services live? Do you have to go and move things over to an alternative location? Do you have to go and stand up a cold site and restore services? Or a mixture of both? I won't go into this much, but there's different types of disaster recovery sites. If we're talking about kind of data centers, you've got hot sites where you mirror the capabilities of the primary location and they'd both be kind of on all the time. And if an issue happens, you can just flick straight to it. You've got warm sites where you might have some servers built, but you might still need to do some manual restoration of the latest data set or a bit more work. And then you can have cold sites where it's more of a bare bones implementation. And you might need to actually go and kind of build servers from scratch, and that's going to take a lot more time. And so you've got kind of cost benefit here. If you've got a bunch of servers going all the time that you're not really using, and you're having to pay for that rack space and pay for the power and the connectivity, that's going to cost you a whole bunch of money. But it's going to be much quicker if you've got an incident occurs. Whereas cold sites are probably going to be much cheaper, but way slower. Cool. So DR supports BCP. And I guess another great way to kind of ensure good resilience is implementing high availability. And so that might be part of your DR strategy, but it probably shouldn't be all of it. Because if a failure replicates in one kind of node of your high availability implementation, it's probably then going to go and replicate to others, and then the service is still not going to be available, so it might be a bad time. And so kind of backups are still a pretty key part of this. With that though, and this is similar for like most cloud implementations, whether it's AWS, Azure, or kind of anyone, is you've got a concept of geographic regions. So that could be Australia East, Australia Southeast, Singapore, wherever. And then you've got, within each of those regions, you've got multiple data centers that are diverse as well. And so you'd have multiple availability zones in each region, and then you've got multiple regions around the world. And when you are doing high availability, you can then kind of pick, are you just going to go and scatter hosts all around the same region, or are you going to go and scatter them all around the world? Again, you kind of got to balance that with cost implications and what's the actual needs of your service. If you've got a sweet website that's hosting pictures of cats, it probably doesn't matter too much. If you've got one of those more kind of critical business systems, you may want to be a bit more considerate of that. With high availability as well, if you've got multiple hosts around the place, you might want to go and load balance over them. But you've also got to be considerate there. What if the load balancer fails itself? Does that need to be resilient? And what's the best method for load balancing? You want to round robin over all those hosts, go for the ones with least response time, least bandwidth, etc. as well. So there's a whole bunch of considerations that you need to think about in there. But I guess one of the key bits of resilience is around backups as well. And this is going to be in every single controls thing that you ever look at. So in the essential 8 and the cert top 10, and splattered all around the place as just being kind of one of the key things that you need to do to have a nice secure system. And it's all around backing up regularly, having different types of backups, keeping offline backups, testing your backups, protecting your backups. So cert's line here is around 3 copies of the data, keep them on 2 different formats, store one off-site and one offline. So kind of distributing your backup so that if something goes up in flames, you've still, in theory, got that data somewhere else. It might just take a while to get it, whether it's a tape backup that's stored in someone's warehouse in the middle of nowhere, or something stored in a safe at home, or whatever the case is, just making sure that it's somewhere else. And some of the considerations of backups is, like, how long does it actually take to restore from backup? Are you aware of that? Have you tested it? Does it actually take 2 days to go and restore from that backup, and your minimum tolerable downtime is 8 hours? Well, in that case, you might need to think of something else, or you might need to go and improve your backup solution so that it can restore quicker. Do you have logging enabled if your backups fail? Or are they just going to keep sitting there failing quietly, and then when you come to actually have a disaster and you need to go and restore from them, you can't? And that happens all the time. Is the data stored by your servers actually as important as the configuration, or is the configuration more important than the data? Do you have that configuration documented somewhere so you could actually build it from scratch if you had to? And just kind of being really aware of what bits actually need to be backed up to keep your service available. I guess some of the things that we see as auditors, a lot is especially looking at people's backup configurations, either that they've been failing for a whole long time and no one's kind of realized, but also just that the backups aren't always comprehensive over all servers, etc., within a service as well. And so sometimes you actually need to know whether your service is available or not. You can just have people go and give you a call and just wait for the public to tell you that your service is down and go, oh, sweet, cool, we now need to go and roll out engineers to get it fixed. A better approach to that would be actually go and put some monitoring in place. And that monitoring can kind of be within your environment. So it can be looking at various servers, going and seeing if there's any failures happening, have connectivity checks happening, have that all going to PagerDuty or whatever the case is, so an engineer can look into it if something occurs. Or it can be testing outside the environment as well. You might just have basic ping tests, or you might go and have something firing to those sites, having a look at what the response is and matching it with what's expected, and then kind of giving you an okay. And then just actually testing your business continuity and disaster recovery services as well, and your resilience. So resilience without testing is a really bad time because you just don't know if it works, kind of like the backups. Misconfigurations slip in, especially after changes occur. And kind of things that happen is, especially I've seen with disaster recovery environments, is that engineers tend to go and forget to go and change DNS entries and stuff. And so when they actually go and have a disaster, they have to enact it, then the hosts, they don't actually know what DNS entries need to be hit, or they need to go and make a bunch of changes. Then they find that they've got a really long time to live on those DNS records, and then things take a long time to come up. So testing your resilience gives you confidence that if something does go wrong, you can come back from the issue. There's different ways that you can test it. You can do tabletop testing, which is great to give you confidence that people know what processes to follow. But what you really want to do is actually do some full exercise and then fail over to actually make sure things work. Chaos Monkey is a kind of cool thing that Netflix came up with, and this is it was like a testing framework kind of thing they came up with in AWS, where it would just go and turn off various servers and services within their environment, and it just tested to make sure that like everything was actually as resilient as they thought it was. And then they also have Chaos Gorilla that drops entire availability zones, and Chaos Kong that just drops entire regions. So that's quite an intense way to test things, and they just have that happening all the time. So they've just constantly got services failing, and their resiliency just keeps everything going. As a quick summary of this, there's heaps of ways to implement resiliency. DR and BCP are different things. One is around technology, one's around your business process. But you've got to be considerate of your business requirements and understand your operating environment before you figure out what you need to put in place. Weigh up the cost versus your requirements. Make sure you put the right level of resiliency in place, put monitoring in place, and test things. And thanks.